Hi class, let's take a look at example 2. And in example 2, they also want us to apply the formal definition to this function. So in this case, we simply have the values of f of t is equal to a regular t. And the actual Laplace transform of the values of f of t, it's going to be equal to the following. So in this case, this is equal to the Laplace transform of the values of t. And this is going to be equal to the actual integral from 0 to infinity of e to the negative st times the values of t, dt. So we're going back to the basic definition. We're going to be evaluating this integral. And then at this point, let me just, this one is going to work out okay by tabular integration. So we technically have the, I'm just going to write the t here, then the e to the negative, e to the, not e, negative st. And this is going to be 1 and 0. And then the first iteration, we're going to get a negative e to the negative st divided by s. And then technically, as we do the second iteration, it's going to be positive e to the negative st divided by now the s squared. Remember that we are pairing them in this format with a plus and minus. So as we translate the infinite integral, I'm just going to say that this is equal to the actual limit as a goes to infinity of, and in this case, we're going to get negative the first term. So negative t e to the negative st over the values of s. And technically, this is positive, but within the formula, we get another negative e to the negative st divided by the values of s squared. And we're going to be evaluating this limit from 0 to the values of a. So we end up with the values of the limit as a approaches infinity of negative a e to the negative s of a divided by s minus a e to the negative s times a divided by s squared. This is technically the first term minus, and when we evaluate the 0 term, this one's going to go to 0. So I'm just going to put a 0 there. And then we technically have the minus the e to the negative s times 0 divided by s to the second. And as we're evaluating the limit, this one goes to 0, this one goes to 0, this one is already 0, and we only end up evaluating the actual limit as a goes to infinity of, and notice that negative and negative, it's going to be a positive. I'll just rewrite it as e to the technically 0 divided by s squared, or this ends up being 1 over the values of s to the second for s greater than 0. So 1 over s squared is what we end up with. And careful with the negative, double negatives. You can actually check the result here. For the basic t, this one is going to end up on 1 over s squared. And once again, make sure you have the shortcuts. If you're evaluating the limits, it'll be of basic functions. The rest of the problems, we're just applying the shortcut. So that's actually it for this problem.